folks. So I'm here to talk a little bit about complexity, because complexity is the thing that I make my brand these days, or trying to remove complexity. And a lot of this, what I plan to talk about is how we built Dark, which is a tool for removing complexity, and all of the tools that we use to build Dark, which is OCaml, Bucklescript, Reason, or whatever we're calling it these days, back-end and front-end. So it's end-to-end in this ML thing that we're all working in. And we're talking about complexity there as well. Oh, this is fun. There we go. So roughly going to run through what Dark is, going to talk about Dark's tech stack and how we built it. And then we're going to talk about the two tools that I use to make, or that we use to make Dark, which may be useful to you. One is called Philippe II, which is a tool for compiling from Elm to OCaml. I make compilers for a living, that's what I like to do. And then the second one is a tool called Tablecloth, which is a library that sits over standard libraries within ReasonML and backend OCaml, which I guess we're calling Reason Native. I wasn't aware of this. This is news to me. And then finally, I'm going to talk about our experience with using Reason OCaml. I'm just going to say OCaml. Please know that I mean all three whenever I say that. That will simplify things for all of us. So there we go. Okay, I'll just stand in this small box here. This will work better for everyone. So I'm the CTO of Dark, which is darklang.com. You might have seen it on the slide that we're setting up there for an uncomfortably long time. I also founded CircleCI, which is another DevTools sort of startup. So this is sort of an area I spend a lot of time in. I joke that my career is convincing people to give me a lot of money to build my fun compiler projects, which is what both of these kind of companies are. And then before that, I did a PhD in static, in compilers and static analysis. Nearly went to work for Facebook, but remembered I hated PHP. I don't really hate PHP, but when you're in the moment, you just sort of feel like you do. You know what I mean? And if you spent a lot of time writing static analysis for PHP, then it becomes a little clearer what I mean. So I'm going to start by talking a little bit about Dark. And Dark is a tool for solving accidental complexity. And one of the realizations that a lot of people are having in this world is that accidental complexity is absolutely everywhere. And accidental complexity meaning complexity that we shouldn't really have to think about. And so Dark was a thing that we started with the intention of removing all the accidental complexity from building backends. And the main kind of accidental complexities that we're talking about are infrastructure and deployment. So by infrastructure, we mean that whenever we go to build a backend, we need to know so many tools. So we need to know Docker and Kubernetes and tons of AWS services, and we need to know SQL and NoSQL and GraphQL and Thrift and gRPC and like Nginx and Memcached and security and observability and monitoring and optimization, and just kind of like an endless list of tools that we need to do. Whereas compared to the front end, while there's kind of a lot of complexity, there's not so many moving parts. And a sort of a visual illustration of this complication. This is the Cloud Native Computing Foundation landscape. And it's all the tools that you use to build Cloud Native. Cloud Native is a word that means roughly Kubernetes. And so to build backends, you need to know, possibly, there's 455 technologies in this slide. And at the very top of the slide, see if, you might not be able to see it there, but where the light is, it says overwhelmed ? It's like, are you overwhelmed? Of course I'm fucking overwhelmed. There's 455 technologies in this slide. So Dark is about removing all of the accidental complexity from coding. And the way we do it is we have a holistic system. We have an editor, a programming language, and infrastructure all rolled into one. So you write code in our editor, you write code in the Dark programming language, and it deploys to the Dark infrastructure. And by doing all this, we manage to remove a massive amount of the complexity. So remove the infrastructure complexity, so you don't need to think about any of the infrastructure. And we removed the deployment complexity. So as you'll see in a second, you actually write code live in production, basically. We call it deployless, sort of like serverless. It's not a term that we coined. I'd be far too sheepish to coin that, but since someone famous coined it, I'm going to exploit it. So the idea is that you write code live in deployment, live in production, and we have tools that make that really safe. So things like feature flags, database migration. So it really simplifies a lot of that complexity. And I'll give you, this is the Hello World application in Dark. So it starts just after it's about to start in about 1 second. So to create a HTTP handler, which is called hello, and responds to a GET, you just create it and write your code there. And then if we open that in production, we'll see that that is live on the internet immediately. There's no intermediate step. There's no deploying something to serverless. There's no CI/CD pipeline. There's none of the sort of complicated things of building backends and APIs. It's just immediately done. And that's the kind of thing that we're doing. So I'm not gonna talk too much about Dark. Just to give you a rough shape of what it is that we're building. And the rough idea is that you can create basically handlers that do the standard things that you want to do in backend. So HTTP responses, background workers, scheduled jobs, and data stores. And it all gets put into a nice, simple package. All right. If you want to know more, there's videos on darklang.com. And if you were at the workshop yesterday, you might already have seen this. So that's roughly what we're making with all this OCaml stuff. So let's talk about how it's actually made. So our back end is OCaml, and our front end is OCaml. And that's nice and simple, right? Everything's OCaml. We get to share code. That's absolutely not true. I'll talk about that at the end. But on the back end, we have the Dark language and its implementation is written in OCaml. Something that you might be familiar with is that OCaml is exceptionally good at building compilers and interpreters and language implementations. It's like the thing it's the best in the world at building. So it was a natural fit. Building the entire language is like 500 lines. It's really easy to build interpreters. We use on the back end we use Jane Street Core as our sort of standard library. And then we also compile that whole thing into JS of OCaml, which is a ReasonML alternative, a different way of compiling OCaml. And it's the advantage of JS of OCaml over ReasonML is that it compiles with the exact same semantics. It works exactly the same. And the advantage of it working exactly the same is if you're building a language or something, you want it to work exactly the same. So while we build our front end in all ReasonML, our back end is compiled into JavaScript by JS of OCaml, has exactly the same semantics as on the back end. And we run that in like a web worker in our editor so that we can show you these really cool things like as you type, we show you the actual value of the code that is under your key as you're typing it. It ends up being really cool. So that's our back end. It's about 20,000 lines of code. And it's pretty stable. We run it in the infrastructure, so we run on Google Cloud, it uses Postgres, uses Kubernetes, has a lot of the same properties as Sean Grove's infrastructure that he was talking about earlier, and a lot of the same problems. Like the talk he gave is basically the exact same experience that happened to us, which is no surprise since I basically follow 6 months to a year behind all of Sean's technological progress, and then just copy what he does. So the front end is the really interesting thing. If you're building a programming language and an editor and infrastructure, you would think, oh, we're going to spend a lot of time on infrastructure. Infrastructure is going to be really hard. Programming languages are hard, but actually the thing that's really hard is the editor. We spend maybe 80% of our time building the editor. That's the thing that's built in Bucklescript, or ReasonML. It's about 30,000 lines of code. Almost, I don't think any of that is generated. And it started life as an Elm app. So we started building this front end in Elm back when ReasonML was a lot less mature. This was about 2 years ago. And at some point, we reached the end of life for the Elm app, and we converted things over to Bucklescript. And the tool that we used to do that is a tool that I wrote called Philippe II, I'll explain that in a second. But so Elm is a beautiful language. It's really, really wonderful in lots of ways, but they have a very strong belief in removing things that do not make the language better. And one of the things that they removed is the ability to directly call JavaScript code, which unfortunately is something that we used absolutely everywhere. And in the last talk, Ricky talked about escape hatches. Escape hatches are a thing I fully believe in. I believe that every language, every implementation, every tool needs escape hatches of some sort. And when Elm removed their escape hatch, it actually removed our ability to stay working with Elm. We could have stayed in the old version of Elm, in the one that still supported it. But staying in old versions of web technologies tends to get you in a lot of trouble, as I'm sure you're all familiar with. I see some nodding. So we knew that we couldn't do that. And there was a tool a library called Bucklescript T. T stands for the Elm architecture. And it's basically an exact clone of Elm within Bucklescript. So we switched over to that. And the way we used it, we did so is using a tool called Philippe II. And Philippe II was a French king in the 12th century. He is one of the stories for which he is famous is that he had a meeting with the English, and the English stood in the shade of an elm tree in a field in a town called Gazores in France. And he stood with his entourage in the blazing heat for several hours while they had their tete-a-tete. And the next day he was so pissed off that he cut down the elm tree. And that possibly is not the most becoming name to choose, but I was in a moment when I chose it, and so that is why it is called that. So OCaml and Elm are basically the same language. You'll see here these are two versions of the same code. It looks exactly the same. They have the same types. They have the same type system. And so switching from one to the other is not that big of a challenge. It's a direct syntactic change. And that was the challenge that we had ahead of us. If we have, I think we probably had 15,000 lines of code at the time. 15,000 lines of code is hard to port by hand. So what can you do to write a tool that converts it from one to the other? And so what we did was we looked at the OCaml compiler. So this is a definition in the OCaml compiler. And this is an expression. So the interesting thing about programming language implementations is that they're implemented in exactly the way that you would expect if you were implementing them yourself. Every feature in the language has a sum type, has a variant. So an expression can be an identifier like x, or it can be a constant, or it can be a function, or it can be a let. And it just, if it's a let, then it has a recursive flag, and it has the things on the left-hand side, and then it has an expression on the right-hand side. It's basically represented in memory exactly as you would model it yourself. And then in Elm, surprise, exactly the same thing. This is the Elm expression, and it's got a literal, this is sort of equivalent to a let, I think. I'm not really sure, I sort of copied and pasted it last night, but it's close enough. And so the two languages are basically identical. So what we did was we took the Elm compiler. We actually took Elm format, which is the Elm formatter, and then we parsed it using that, and then put it into Philippe II and did some translation, and put that into the OCaml compiler, and then spat it out the other side. So it looks roughly like this. So we started with Elm. Elm format wasn't perfect. It has its own built-in JSON format, which tries to be really pretty and altogether too clever. So we used a deriving one instead to just get every value spat out of it. Then it came to JSON. We parsed that JSON in Philippe II, and we output OCaml IR. IR just means intermediate representation. It's just a fancy word for the memory that we use to represent your program. And then everything else was done by other stuff. So gets spat out. We put the IR into the OCaml compiler, which then printed out some ugly OCaml. And then we used OCaml format to make it pretty. You could use reformat to put it out as ReasonML and to make that pretty as well. And so very, very simple project. It took about 2 weeks end to end, and then it took about a month of engineer time at the end of it to make it actually work, because if you try to compile 15,000 lines of code from one language to another, that isn't exactly the same. You're still going to get you're still going to get some problems. So yeah, we're in OCaml. Wonderful. But of course, there's a bunch of things that don't go well when you're dealing with OCaml, and one of these we built a tool for. So one of the big problems we had once we switched over is now we have back-end OCaml and we have front-end OCaml, and they don't share any code at all. So like, how do we deal with this? It's a relatively small team. At the time, we had 3 engineers. Did we have 4? I think maybe we had 4 engineers at the time. Now we have 6 engineers. So it's a relatively small team throughout the life of this project. So how do we switch it over? So I made this thing called Tablecloth. And Tablecloth is a standard library which wraps other standard libraries on the existing platforms. So it wraps Belt on the front end, and it wraps the Jane Street core on the back end, and has the same interface to these 2 libraries. And if the interface is something roughly like this. It looks exactly like you might expect it to. It's got list map and string to list and all this sort of fancy things. And you install it, or you implement it by just calling open tablecloth, and then it overwrites all the existing types. And the reason that we created this was because we had a bunch of problems. So we had one issue that we have, and if you've ever written any backend OCaml, they use underscores for everything. And on the front end, we use camel case for everything. And snake case and camel case are different, and you keep forgetting which one you're supposed to write and so on. So if you've got a standard library that works on both, which one is it supposed to be? Is it supposed to integrate with the standard OCaml way of using snake case and underscores? Or is it supposed to work with the Bucklescript reason-y way of doing camel case? And honestly, bigger problem than I thought. Similar, they have different libraries and functions. The thing was going on at the time, I don't really know what happened with it, that front end was going towards pipe first, whereas the back end used pipe last. And Belt is written to support one, sort of on the other, and that is quite a big difference between the 2. And then Core does not work on the front end. Belt does not work on the back end. Belt was sort of incomplete, certainly relative to Core. Core is huge and mature, and then Belt doesn't really have support for PPX. Or perhaps it didn't at the time, but certainly the PPXs that we were using on the back end weren't really supported within Belt, and we wanted to reuse those PPXs because they were kind of useful. So our solution to all this, we took Elm's standard libraries and we basically wrapped them. I say we wrapped them, we re-implemented them with exactly the same interface. So the Tablecloth has the same API as all of Elm, and the reason for that, partially, we used the Elm library, so being able to slot something in was really useful, but also because Elm has really, really well thought out standard libraries. Actually, Elm has really, really well thought out everything. It's sort of a masterclass in beautiful API and library design, and so the simplest thing is like let's just copy them. They've put all the work into it already. We solved the camel case and snake case thing by having both. So any function that you want, if it's called, to string, there will be to capital S string, and there'll be to underscore string, and it'll just work the same, exact copies of each other, and hopefully the optimizers will remove them at various points. The front end one was backed by Belt, and the back end one was backed by Core. So we just called the functions and manipulated the parameters to make them do exactly the same thing, and occasionally had to implement something, but not too commonly. And then the solution to pipe first and pipe last was that we used labeled arguments. So every function basically has one positional argument, and so it doesn't matter if you prefer using the pipe first operator or you prefer using the pipe last operator. All the thing that you would pipe into it is going to be a positional argument, and all other arguments are going to be labeled. And that has worked really well for us, actually. It's super. It has made this distinction really nice, and it's sort of what Core does on the back end anyway. They use labeled arguments for almost everything, and that's really nice as well. So things that we intend but have not gotten around to are support for PPX drivers, not throwing exceptions, all that kind of thing. So I want to talk a little bit as well about the language support. So the difference between our experience in Elm versus our experience in ReasonML is we spent a year in each. They are both the sort of preeminent statically typed functional the ML derivatives of the front end. There's this other thing called TypeScript that you might have heard of that I guess is statically typed on the front end. So not going to talk about that at all. But we can't really claim that these are the only ones. But these are the ML variants that are on the front end, and they chose a lot of different things. And one of them is that the language is kind of different. So OCaml is this old language, and it doesn't really have a whole lot of user experience that has gone into it. It's not a beautiful language. That's one of the reasons that ReasonML was created. It's not a beautiful language syntactically, but it's also not a beautiful language semantically. On the other hand, Elm is an absolutely gorgeous language. If you haven't tried it, it is hard to describe how a programming language can be as beautiful as Elm is, but it is. But unfortunately, there's things that they don't do in Elm that Bucklescript does that I think that Elm could learn, and vice versa. There's a couple of things that OCaml could really improve the experience of coding that Elm does really nicely. So the first of those is that constructors in Elm are callable directly. So if you want to wrap something in an OK, that's a function that you can apply. If you want to pass a function that wraps something in a constructor, it's just an argument. You just call it with just or whatever it is, some I guess. But that's not how it works at all in OCaml. Instead, in OCaml, you need to create a lambda function. You need to create I'm blanking for the word that I'm looking for. Yeah, you need to create a lambda function, and you need to wrap that. And we end up doing that in tons and tons of cases. You see it in JavaScript a lot as well. And Elm has a really nice experience around that. It does it with tuples as well, and then its standard libraries is built around using pipes really well, and it ends up being this really beautiful experience to code in Elm, which is not what we got when we had switched to Bucklescript, and we sort of tolerate it, but sort of reminisce to the better days in the past. On the other hand, OCaml has lots of cool shit that we really like the ability to have multiple match statements or switch statements that are different types, and to sort of unify them, and to add the when statements in, I forget what that's called in ReasonML, maybe it's when, maybe it's where, but it's super nice, and once you start using those, you realize that it simplifies a great deal of your code, and we really enjoy using that. On the other hand, there's also this object thing, and this class system. Does anyone know what that does? I really don't know what it does. It has these weird things like functors and GADTs, and I was in a conversation last night at the speaker dinner where people started talking about functors and GADTs, and I immediately zoned out. I had no idea what those things are. And honestly, no desire to learn. I don't think this should be a thing that someone should be required to understand in order to build web applications. That doesn't seem like the right trade-off. Going back to the standard library in Elm is glorious. This is something we tried to help with Tablecloth, try to make something as glorious for the OCaml ecosystem. I think we sort of got there. I think it's really nice. I think you'll enjoy using it. Looking at what we lack that Belt has. Belt has all these functions ending in U, ending in a capital U. I don't know what they do. We don't use them. I put them in the category with GADTs and sort of sweep them under the rug and hope they never come up. But I think it might be something to do with performance, and if someone could tell me what they do and should I actually be using them or know what they do, that would be helpful. Documentation. Documentation in Bucklescript and ReasonML is bad. Does everyone know this? Am I alone in? Okay. Okay, I thought I was going crazy with this, and that somehow everyone had figured it out. I was trying to use the documentation to understand how to do the foreign function interface things, and I wanted to wrap an object that had a little bit of a complicated thing. And there's 2 pages in the Bucklescript thing, and then there's one very long page in the ReasonML docs. And I have used a lot of foreign function interfaces, and I've worked on JavaScript compilers. And I have a PhD in compilers and programming languages, and I could not figure out what I was supposed to do from the documentation. And I think that's not me. I believe it might still be me, but I think it is probably the fault of somebody else. And if you are that person, well, I think you should apologize. So the coming from Elm, where the language docs and the standard library docs are absolutely amazing. It's really a hassle to come to Bucklescript, try to understand how this language works. And this is knowing OCaml already. And also we hire junior developers. We hire people who do not have a year of OCaml to try and understand how to write stuff in this. And we kind of need better tutorials. We need better documentation. I suspect somewhere in Facebook, people have written this documentation because presumably there's hundreds, possibly thousands of developers in Facebook who presumably have some sort of like good onboarding, but it certainly doesn't exist in the community at large. Ecosystem, final thing, is there really aren't that many users. Has anyone noticed this? It's not a very thriving ecosystem. OCaml is worse. Like OCaml is the back end OCaml, I guess what we call Reason native these days, is sort of flatlining. Elm is doing very well. Bucklescript is doing middling, I would say. I could be corrected on that, but we're not in a wonderful place, and I think that there's a bunch of things that we can do to address that. In terms of interacting with the rest of the ecosystem, so Elm is incredibly bad at talking to the rest of JavaScript. You have to wrap them, and if you wrap them and they don't think of the world in exactly the same way as Elm, which is a very prescriptive way, if you've ever used Redux, it's sort of that model. Whereas in Bucklescript, while the documentation around it might be horrendous, you can actually directly call JavaScript, and that is a super useful thing, and it can go both ways. So the escape hatches are working live and well, and this is the thing that enabled us to switch, that caused us to switch from Elm and caused us to switch to Bucklescript. So that's a thing where there's not a whole lot of libraries within Bucklescript, but we can sort of iffy use the JavaScript, although it's still a huge amount of work to wrap a single JavaScript library. So our experience report, how things are going with Dark. So we've been working on this about 2 years. First year in Elm, second year in Bucklescript. On the back end, both years in OCaml. On the back end, we are having a lot of operational issues. If you saw Sean Grove's talk, it's kind of the same. This is not a good place to be. It's not good. There's not a lot of movement. Everything sort of works, but sort of doesn't. I kind of thought that ReasonML was leaving the native world behind, but I saw a ton of talks on using it today. So there's clearly some desire, and perhaps the killer feature of OCaml is that we can write both. But right now we can't really write backend stuff as well. It's horrible. We have a bunch of We basically pay Google Cloud twice as much as we should to get maybe a quarter of the performance that we could if OCaml multi-core came along, which it will any day now, promise. So on the front end, I would describe our happiness on the front end as middling. It's not bad. We're not looking to move off, but we're also not like super ecstatic with it. And part of this is that part of the happiness actually comes from the fact that we have a fairly custom app. We're not really trying to reuse a lot of the community stuff, and most of the time that we hit trouble is when we hit the community stuff. And part of the problem from us is that we're using this Bucklescript T thing. So we're using a thing that's sort of on the side of the main path. It seems everyone here possibly using Reason React, and perhaps that's a much nicer experience. I don't know, because we don't use it, but we're sort of off to the side, so we may have done this to ourselves. And as we start hiring more and more people, we're starting to think, like, is it a good place for us to be? Is this the right thing, since none of the engineers who are coming in are going to know how to use it? Are we going to be able to teach them, or is it better for us to switch off it? And we ran through this exercise recently, and we basically feel that we've nowhere to go. There's nowhere that's better. So things aren't terrible here. They're fine. And we're probably going to stay here while things are fine. But from that, we do get a little bit of sort of suggestions, perhaps for the community, and this is meant from a place of love, from a place of wanting the community to succeed. I'm a little bit of an outsider on this. I did get to go to the speaker dinner, but I didn't really know anyone there. So the things that I would say about this community is that it is expanding rapidly. And at some point, when communities expand rapidly, they have to contract. And this is a necessary precondition to making things nice. So if you think about this in the JavaScript world, we had this huge explosion back in the 2000s, where there was like MooTools and YUI, and there was a bunch of other things. And the world, it exploded for a while, and then the world eventually settled on jQuery. And then we had Backbone and Angular and Ember, and the world eventually settled on React. And there's another explosion, Vue and Svelte and that sort of thing, and that'll settle somewhere. And each time we'll get happier. But the important thing is that after things explode for a while, things need to contract. And we're definitely in the exploding phase. Like there's lots of things being built, and none of them work together. We have 3 names. We can't even talk about the same things. Like we're talking about OCaml, and we're talking about Bucklescript, and we're talking about ReasonML. And do we mean something specific by this? When we say ReasonML, do we just mean a syntax? With OCaml, does it just mean a syntax? I don't really know what people are saying necessarily, and I think I have a fairly good sense of the ecosystem. And this plays out, like if you're a beginner, this plays out if you're searching for things on Stack Overflow. It even plays out in the communities. Like there's very definitely a split community. There's the people who are doing OCaml, and then there's people who are doing ReasonML. And there's some people who are doing Bucklescript, which for some reason includes me. And they're sort of within the ReasonML thing. It's very confusing. And the OCaml people have started their own discussion forum. So there's reason.chat or reasonml.chat, and then there's like discuss.ocaml. And no one's really talking to each other. And it seems... Thank you. And it seems like you all know each other. And Jane Street sponsored, so like presumably there's some cross. But yeah, I don't know. I don't know what's happening. And that's really a problem. And I mean, even if you install ReasonML, you do npm install bs-platform. And lots of the libraries that you use start with bs instead of like re. And what is happening? And I know that like there's a new name and there's an old name and there's this other thing, but like in order to make this accessible to people, you kind of have to make it one thing. And as it expands and it explodes, great, but yeah, let's make it one thing again. So I think that there's a lot of really cool things that are going on. It seems that a great deal of them don't work together, and that it's hard to tell what works and what doesn't. And if you're using one thing, like I found a load of PPXs that don't work if you're using the OCaml syntax, which is what we're using. And maybe the thing here is the ban using the OCaml syntax. Maybe we're doing it wrong, and maybe the actual thing we want to do is like everyone has to do it this way. And everyone having to do it one way is often better, because there's less things to learn, there's less things to, less documentation to have, less paths, less things to integrate. So I think there's still a lot of complexity in this. But honestly, I think it's still the best thing out there, and I'm super psyched for the direction that it is going, and for things getting simpler. Thank you.